So I hope we will be able to continue on this. So can everyone go on mute? Whoever's yeah. All right. So the last I hope you can see my screen. Um, the last we saw was we created an API. We onboarded an API, Temenos. We secured it with an API key. Then but however, to test it, right, we needed to create some a consumer or a client so that we could create credentials under that client. So we created an application over here. As you can see, we used an existing app that is the internal app which is a part of the same organization. And within that, we created an additional credential here, which we are going to use for testing. Okay, so now we are all set. So I'm going to jump into my Postman. And this is my client, going to pose as my client. I already have some ready test cases for us today. And I'm going to show you how to test it, right? So if you see, if I just go back here and I go back to the API, um, you can see that this is the final URL, right? So it's Axway API and APAC demo. This is the same host that my gateway is running on, with a different port, of course, because this is the traffic port, and this is the relative path, right, of the API. So this is the base URL path, and then this is the resource path or the method path, right? So I have the sample request here. All I need to do is I need to just change the key because I just now regenerated it, right? And uh, and that's it. So let me just say send. So this is typically going to go back now to my gateway. The gateway is going to make a call to Temenos, and then the Temenos is going to then respond back in that fashion. So if you see the response here, right? The response here is that we have got first of all, we got a 200 OK response. We can see that this is a live customer. So I'm trying to get the customer details for this customer ID. This is the test data that I already have. Okay. The name of the customer is Ian Norman, and these are all his account details and all that. Right? So basically, this was a success. I could get this tested. So if you can see, leaving the break that we had with switching the calls and all that, it's pretty straightforward and um, quick to onboard an API, just as I did, and secure it. Now you can do further on advanced things with this API, right? So if I go back to this customer services, I'm pretty much change the authentication, right? I can change the authentication once it's onboarded. The management of or the API lifecycle management is much more simpler than, right? So you can change the authentication to OAuth or to SSL or a lot of other options, right? And say your organization has something very specific. Your organization needs to do a security based on something very unconventional, right? In that case, we have something called an invoke policy as well. So what is this? This is essentially giving you a bucket to build a policy, which I'm going to touch upon in a later stage, and invoke that policy here. And policy is nothing but it's like a set of rules, right? So you can actually build a security policy or authentication policy of your own if you want to, and you can invoke it here. So it gives you all the options. It gives you all the ready options as well as it gives you all the customization options as well. So let me get back to the Excel sheet. So this has essentially taken care of the first thing that I was trying to show. That is the onboarding of the API. I just want to also touch upon the last bit here, that is the API portal. So now that we have onboarded this API customer services, right? If you see the status of this API, the state is unpublished. That's more like a draft state, and this is more like the development time state. Say I want to now make it live for my consumers, right? This is API manager that we're looking at. This is a user interface for API administrator, right? But my consumers don't want to come here. My external consumers, the outside world, right? So I want to make it available for them. So what I do is I click on this and say publish. So I'm going to publish it now to my portal and say okay. And you can see now that the API is published. I can go into jump into my portal now. So let's jump into the portal. Okay. This is the homepage of our portal, but typically, this is the most basic theming. But we have very advanced portals that we will build. You can open up any of our, maybe later I can show you some portals as well. But the idea is that this is a complete customizable portal where you can do web-based customization using, the Joomla framework. Okay. So I'm going to now sign in as a developer. So I'm not signing as an admin. I'm going to sign in as this developer. So this Axway.amz is the developer of the same organization where I imported this API, right? I'm going to sign in. And if I go into the APIs part, right, he can now see the Temenos Customer Services API, right? So you can only see this. You can go in here and see the documentation, okay? He could also pretty much do the testing if he wants to, right? So he could go into any of the options, try it out, get the responses the same way how I tested the Postman. You can see the keys he has right at this point because we have already subscribed to one app, right? But other than that, what else can he see? This is of course, this is the host and the base path and everything, but he can also download the spec from here. If they want to use this spec to, for its development purpose, he can download some client-side code. This is very handy. So say, for example, you're a mobile developer and you want to build an Android app to consume this API. I can just download the code from here and all of that. Can see his usage, right? He can see his usage, how many data, how much of, how many requests has he tried, tested across a span of time, as well as he can now create applications or subscribe, right? So he can basically either create new applications and manage his keys and all of that, or he can use existing apps and subscribe. So that being said, this is what he will do. As a consumer, you would like come into this portal, look at the documentation, test it, and all of that. And all of this can be done in a self-service way. This can be a complete different domain, the portal. It can be running for external world. All there's an entire, if you there's an entire auto sign-in or self-service way to register. It's just like how you register any other any other website, right? It will send you an email, an activation mail, and get approved and all of that. And you can pretty much, if I give you this URL, you guys can actually enroll yourself to this organization and see the API. So it's completely service based. And once he does that, he has a view of the APIs. Also, as a consumer, you have the view of the applications, right? So all the apps that I was using internal app over here. If I go into internal app and I edit app, I can pretty much create new keys again over here, right? I can generate OAuth credentials and all of that. So this is, I just want to highlight this because, we want to make life of a consumer simple, and even you would want to do that, right? And that's one of the reasons why API management is useful as well. There are a lot of other tabs as well, like you could look into Help Center, you could create like FAQs, discussion forums for your developers where, you could like have active communication happening for APIs. So this could be like, you could also create a blog post showing you how to enroll on this particular set of APIs, how to generate the keys. You can build all that documentation here. So a lot of things. So this is how typically we would build the portal, and this is how you would see the the APIs that you expose. So one of the portals that I want to quickly show you is bank. It's a German bank, but I want to give you a different flavor. So this is one of the portals that we have. Um, maybe. All right. So this is built completely on our portal, right? This is built on our portal, the same portal that you see, but the UI is completely built as per their theming. So it has products, guides, open banking, and news, right, as the options. And then you can go into the APIs and discover the APIs. Go into any one API here, and it gives you complete documentation of how to use the APIs. I can even try it out because these are public APIs. I don't even need to sign in actually. Okay, so I can literally go in here and try it out. So this is the sort of portal you can build with our Joomla framework, right? And you can see you can, one second, you can pretty much see the request response and all of that. So this is one flavor. Another flavor for more local Bank of Singapore. Um, just bring that up. So this is for UOB, which is also using our portal. And you can see that, they have completely differently changed. They have changed it, right? They have made the UI very much different, and they don't have any public APIs. Like I'm not able to test anything, but I just want to give you a feel. So these are the APIs they have. But if I want to see the documentation, it's gonna, ask me to sign. And this is not what is gonna work. But yeah, so the idea is that they have a different set of options as well. They have stories and they have news articles and all of that. So this is how creative you can get with your portal. And I just want to give you a feel of how different banks use our portal. And this is something which, there are a lot of public examples that we can give you, but I think you get the idea, right? So this is the most basic theming that I show you from Axway, which comes as the default theming, but you can change all of this to that, right? One quick view before we move on to this is the administrator view, right, of this portal. So when I log in the same portal as administrator, here is where I can do all my customization, right? And that's what is powerful. So I can literally go into all menu items, and you can see I have all these options that you could see on the screen for me, right? And under each of this, say APIs, I can log in here and I can change things. I can change the way things look. I can change the display, the catalog items, what I want to publish, all of this. So this is just with the configuration. I hit save and it will start to appear. So this is as easy as changing, on a website. So it's a content management system, right? So this is something which is very powerful, and this enables you to build very creative and very good portals and helps you manage it also in a very simple way. Okay. So with that, we finished our first thing. This usually takes time because we're doing everything from scratch. And we could see now how we onboarded an API and API management. We saw the portal, we saw the entire flow, we tested on API, right? Let's move on. Now, the next one we're going to look at is demo use case matrix. So something that we wanted to see how we maintain access management on the API, right? So for that, I had touched upon it on a high level, but I'll just quickly look at it again. If we go back to API manager, right, and go to the clients tab, here is where we maintain, here's how we maintain the access control, right? So the topmost level, we have an organization, right? For everything, every API is going to be, any API is going to be imported into any of these organizations. We use digital team for importing the first API. So we're going to open that. This is the organization details of that digital team, right? But you can see there's an API access here. So by default, if I'm importing into the organization, of course, it will be added, right? So it is Temenos customer services here, which is added. But I can also add and revoke access to any new API. I can add, or I can even remove this. If I remove an access to this API, it will stop appearing into my portal or anything. So this is the top level access at the organization level. This organization, as I told you, is linked to users and applications, right? So if I go into users is the application developers. Like this is having all the users. So these three users are part of digital team organization, right? So any of these users are somebody who can access all the APIs in this organization. Okay, so organizations having a set of developers and users. Now, each of these users can have two roles, can have either a user role, which is a normal user developer, or an organization administrator. So you can be an admin of your individual organization. Okay. So I used this developer, right, in the portal. So this developer has an organization administrator of that team. But you can also have you can also have access to other organizations if you wish, right? I mean, that can be given. So I can give him user access to other organizations as well. So this can be done via this um, interface, right? So organizations, developers, finally we have applications, right? So applications are the consumer apps where we're storing credentials and all of that. And this will again have a further access control on APIs. So the topmost access control was at an organization level, but any application that the consumers built, right, via portal, and they say, okay, I want to access this API, this is the credential, you can further on fine grain this access here. You can again create API access, or you can revoke API access from here. Not only that, you can build authentication. I mean, you can create credentials, which I showed you. You can also do quota management, which I'm going to touch upon a little later. And you can share this credential with other users as well. So all of this can be done via applications. Okay. So to summarize, when we have organizations, we have the topmost level access. Every user and application under this organization has direct access to this. It's like a global access. But under the organization linked to the application, further on, the application level access as well. So at an application level, you can further on revoke the access. Okay. So why is this useful, right? So a particular organization might have 10 consumers or 10 consumer applications. At an organization level, if you have 100 APIs, all 100 are open, right? But at an application level, you might say out of my 10 consumers, there are two consumers who I don't want to give access to everything. I just want to give them access to 10 APIs. That's where you'll control it at a consumer level. Right? So two levels of access and developers under that organization. This is all the RBAC you can do across APIs. I have logged in as an API admin. This is the last bit I want to leave you with. This is a super admin. Okay, so this is an administrator who can see all organizations. That's why you see everything, right? You see all organizations. So I have logged in as an API admin, and this could be your administrator who's looking through the entire ecosystem. So API admin as your administrator or a super admin. You have then the organization administrator, which is like the admin of that organization. And then you have users, which is users, the developers of that organization. Okay, three level of users as well. This takes care of our access control for APIs. Okay, moving on, I'm going to just color these so that we have an idea of our progress. Okay. The next thing that we need to check on is the version control, right? So the version control is maintained with. So let's just take the same API. So we have customer services, which is a published API. Let's create some versioning, right, for it. So I'm going to click on this, and to create version. So versioning is typically one way to maintain versioning is to maintain it via the query string, right? You have a version control. You have multiple front end components for your API, which are pointing to the same backend, that is Temenos. So say I want to make Temenos version 1 and version 2, right? So I'm going to first let me unpublish this. Let me change this version to 1.0. Okay. So that so that the documentation is proper, right? So we have version 1.0, and what I'm going to do is I'm going to now export this configuration. Now this can be done in many ways. Just to save time doing it as an export, so I'm exporting this API, right? And I'm just going to replace it, and I will re-import this back. Okay. Right. And I can import it in another organization, but because I'm showing you versioning, I'm going to import it into the same organization team and import. Now that I have this API, I have two APIs, right? You can see I have two front-end APIs rather, which is both are 1.0, and it's showing me a warning that it says that it has a duplicate path, right? So because the paths are same, and that's something which is not it's not possible to route the request, incoming request, right? Because which one do you route it to? So how do you understand the versioning? So we maintain this. We'll have to change a quick setting here on API Manager. We have query string version routing. So if I enable this and I set this parameter, what's going to happen is now for every API, I would need to set the version as well. Okay. So say for example, this is the second API I pulled out, right? That is 1118. Yeah. So I get an additional field here, which was not there before. It's query string routing, and I can put a value of the version, right? 2.0. Apply. Okay. Similarly, I could now uh, also go into the earlier one and put 1.0, right? And say apply. So now the warnings go away. And typically the method signature, the invocation of this request, right? You can call this request with the word. So to demonstrate it, what I'm going to do is I'm going to change the, let's change, okay, based on the time, this is the one. Let's change the documentation of the second API to 2.0 as well so that it shows up in the index list. Okay. So you can see there's 1.0 and 2.0, and the second API that the version 2.0, right? I'm just going to change the authentication of inbound security to anything, maybe you want. All right. So two APIs, both calling the customer services backend. V1.0 is using API key. V2.0 is using OAuth. Okay. Now if I go back to my Postman, right, and I test it, okay, and I just now I'll have to give the version information. And if I give 1.0 here, which is the first API, and this client is having API key authorization, right? And I say send, I should get the response, right? So it's basically trying to get the response from the 1.0 API, which is exposed. Yes, I get the response, success response. But if I change it to 2.0 now, the same API, but I'm giving a different version info and say send, I'm not going to be able. It's a bad request because the reason is that this particular API is not having API key as the authentication, right? So this is how you'll maintain versioning. You could have multiple versions of the same backend, exposed on a front-end API. All right. So this takes care of versioning. The next thing we want to look at is rate limiting, and I'm going to take both of them together. This is going to be rate limiting and um, uh, you know alerts that we set via email or Telegram or whatever, right? So I'm going to show you that. For that, let me do a quick cleanup so that I don't have to enter a lot of fields when I'm doing. There's a lot of use cases. So I'm going to, for now, for this demo, I'm going to deactivate versioning and delete the 2.0, right? I'll just keep one of them so that we don't get confused. All right. So now that we have everything, we're going to look at how we basically now can rate limit or quota manage these APIs, right? So for doing that, customer services, as you know, is linked to this app called internal app, right? So if I go into the app at the app level, right, I can, as I told you, we have, other than authentication, we have quota. So, okay, before we jump into this, let's look at what quotas we have. In API Manager, we have some default quotas, which is system and application default. What is this, right? The system is the topmost level quota. This is setting a limit or a quota, right, for all the client applications, like all the everything that's exposed. So basically all the clients that are there, you're setting at an API level, of course, you're setting a default quota for all the consumers. Okay, so this will be the highest bucket. So this can be like, so if you want to avoid crashing of your system or something, you could build something like this, right? Second level quota is default quota is the application level quota. So now this is a default. If you don't set anything, this is your default that gets set for per application, right? These are the two defaults. One is at a global level, one is at an application level. But once you set these defaults, you can then go into applications and further override these defaults. Okay, so I can override a default application quota, and I can set my own quota irrespective of whatever set for me externally. So I can now override this and set the quota for customer services, right? And I can set it for either all methods or I can select it per method. So method specific quota can also be set. And I set like, say, I give it very small number, right? One message every 1 minute. Of course, you won't do it, but I just to demonstrate. Okay. And if I now hit this same service, I'll just remove this parameter. So it shows me too many requests, right? Because it's only allowed me to hit one request. I hit one request, success, second one, too many requests. So that's this quota stopping. So it's as easy as going into API admin and then accordingly selecting the quota um, for your APIs, right? Now, say I want to build some more customized logic around quota. How will I do that? Let me remove this first. Okay, I'm going to remove this. And let's go back to API. Okay, our API is customer services. Now, if we go into outbound, right, there are multiple things that I can do. So the default communication is the gateway hitting the backend. But before it hits the backend, like the pre and the post part of it, I can do some processing. And that I can do by clicking on this advanced tab. If I on this tab, right, you can see multiple things added here. So you can see a request policy, a routing policy, and a response policy. So this is a way to add additional things like any sort of pre or post processing that I want to do before the call hits the backend. So if I want to do pre-processing, I'll create a request policy and I'm going to like apply it here. So before hitting the backend, it will do that pre-processing. Post, of course, will be in response and routing. Right? So the default routing is it is you calling this API proxy policy, which means it is the bare minimum policy calling the customer services. But say I don't want to do that. I want to do a custom routing orchestration. We'll see some examples later as well. But if I want to do that, then I can change the routing as well. So if I click on this, I have a quota breach check which I want to do. Okay. And that's going to internally route me to policy. So if you see now the thing has changed to route to policy. I'm using this policy as my routing backend. Okay. And I say apply. All right. What's going to happen is I'm going to test this again and say send. Right. Send again. I think the quota in that policy is 2. So I'll have to send it 3 times. Right. So the third time it shows me too many requests, right? Now, that being said, what I should also have received is an email. Okay, my pop-up is disabled because I'm sharing screen, but this is the email I've just received. Okay, if you read this email, it says the quota for the service. This is the service URI that I have set, right, with this ID has been breached and cannot be processed, right? If you see, this is the email that's come on 1st of July at 11:28. And this basically is a way to set up, like, say, for example, if you have any sort of quotas or any sort of alert that you want to set, I just wanted to demonstrate that we can, at any such events, we can trigger out email to admins and all of that so that they understand that there's something going on wrong and they probably could log in there, or you could modify this. This is a customized text. I have templated it myself, but you can always change it to whatever you want. You can provide a link here. You can do whatever, right? You can probably send necessary alerts and such event. So now, so this is what I wanted to demonstrate. So before we look at anything else, right, I want to show you that what happened inside this quota breach policy, right? Let's look at this. Right? So for showing you the quota breach policy, I have to now introduce you to Policy Studio. So Policy Studio is this, as I said in one of the slides, it is this design time tool where you build policies, right? It's a tool where we build flowchart style policies, and policies are then pushed on the gateway and then they're applied. So over here, there are a lot of policies, and one of them is the quota breach. So if I just look out for quota, so I can see this quota breach check policy, right? And let me enlarge this portion. So this is a policy, which is this is how it looks. So it has these, each of these blocks is a filter, okay? And if you see on the right side, this is the palette having many filters. If I just say HTTP, I get all HTTP filters. I just have to basically drag and drop here, put in some details and say save, right? And each filter has a success and a failure path. So that's how that that helps you to decide the, you know, the transitioning of from one filter to another. Okay. So that's how you do it. And then you basically configure, and this is how you can intercept a request and do whatever you want here. So what we did in this policy is we extracted, of course, some attributes, which is from the headers and query string. Okay, and then we use this throttling filter. This throttling filter is nothing but is also the same as what we did outside, like, you know, on the API manager for setting quotas and rate limits, right? But this has some advanced options, right? So it basically gives you a way to select the algorithm of throttling. It gives you allows you to set how many requests you want to set. The same thing what we did outside. Okay, it also helps you select on the basis of what are you going to limit, right? This is on the basis of address, but you can change it on any other request attribute. Okay, you can also select time, like when do you want this policy to be applicable, right? When, what time, what day, and everything, all that. So there's a very some advanced things that you can do on this throttling filter, right? And once you have this filter, this will either so till the quota is, you know, is not breached, right? It will be a success, right? Otherwise, it will throw failure, right? So it will be a false that will be the response of this policy. So if it's within the quota, it's going to go into the green arrow side, and then we're just denoting it's below quota, and we're doing default API proxy routing. This is the same thing, like, you know, just pushing back to the Temenos service. But if it's failure, that is it's breaking the quota, then we are using an alert filter. Okay, alert filter now is telling configuring something like alerting the users whenever there is a, you know, whenever this event occurs. So I have multiple ways to alert. If you see, there are a lot of notification mechanisms that I can use. So I use the email alert. I've already pre-configured this. Okay. Um, you know, you can essentially build templates and all of that and send out the email. You can also do things like sending it out on syslog or, you know, other channels. Okay. So I send the alert. Yeah. There, is that is there a question? I mean, I just heard some.
Okay, go ahead.
Okay, no worries. Okay, so that's why I fill the alert and then I reflect the message back. Okay, so this is the alert policy. I just wanted to highlight two things here. One thing is how we can write an advanced policy for throttling, even though we have the basic on policy on the API manager. Other thing is also introduce you to API policy studio. Okay, so once we build this policy, all we do is we deploy it. Like, you know, there's a deployment option. This is a manual way, but there's also an automated way to do these deployments, which I will show you later. Okay, you connect to your gateway host and then deploy it. Once you deploy it, you see this policy under this drop down. Then all you need to do is select it for the specific API. Please note that this policy is a generic policy. It's not specific to any API. I mean, you can make it specific, but you can write policies generically and you generate one or two or three common policies, and you use those policies for all your API, right? You can have some global policies created. Like, say, I want to do some transformation for all my requests and add some metadata, right? Just to keep a track of whatever requests are coming to my organization. You can you can just create that one generic policy, and you can apply it to every API, or you can even go on your settings and apply it at a global level. So there is a global way to access this policy. So you can see at a global level, if I enable this, I can enable what policy I want to apply as request and response. And then this will apply for everything that comes in. Okay, so it's a very useful way to govern and secure and kind of maintain your APIs. Okay, when it comes to like all sort of security or restrictions or access control and all of that. So this takes care of these 2 points. I showed you rate limiting. I showed you also with rate limiting. I also showed you alerting via email, right? So let's just mark this out. The next thing we are going to touch upon is API life cycles. Okay, and for that we go back to API manager. That can be managed directly on API manager level. I'm just going to change this back. So earlier I showed you how we make the API live, right? This was the API. We publish it. So let's do that again. Let's publish it. So this is one part of the life cycle where we publish it and it gets available on the portal and everything, right? Now this API, at some point maybe you want to now not use it, or you have a new version, or you want to deprecate it, right? So you can select this and go in here and deprecate it. Okay. So the other options you can do, of course, you can grant access to this API to other organizations like this. Okay, you can select organizations, grant access, or you can say, okay, now as a part of the thing, I'm done with this API. I don't want my consumers to. I want my consumers to start using. Maybe I have a new version of it also, like how we showed before. Right? I have 2.0. I want people to stop using 1.0. So I will just say deprecate. Now, during deprecation is one thing which will show your consumers the API is deprecated, but they can still access it. But you want to give them enough time to make the changes to the new API and say that, okay, this is a deprecated version. You got to stop using it because after a particular time it will retire. So you can also set the retirement date. So you can say the retirement date is today I'm deprecating it, but my retirement is tomorrow, right? I'm giving you 1 day to change, although you'll give more time for consumers, but I'm giving 1 day and I see deprecate. Now you can see that this service here is showing deprecated. And the interesting thing to see is in the portal, how the consumers will see this service. If I go in here back and I go back to APIs, right? I can see the Temenos customer services now shows as deprecated. It also gives me this message that it retires on 2nd of July. Right? So this gives all my consumers an idea to understand that this is going to be deprecated soon, and this is something they need to start using the new version of the API or whatever. Right? So this is the lifecycle management. I mean, these are all the steps that we can do from onboarding to publishing to the application to retirement. Okay, so this is the complete life cycle that we take care of. So this is done. The next is the next are 2 points which I'm going to take together, which is both talking about analytics and performance monitoring. Right. So what we didn't see until now is all the testing that we did. We didn't see all the stats, right? So for that we have another tool called API Analytics. Out for you. So this is basically looking through all the data that came into the system, and it's going to typically have various levels of records, right, that it maintains. So one is a system level record. It's going to check for at an API instance level, what's my what are the sort of successes, and so this is a complete global view of how many APIs were there and how many got blocked, how many were successes. You can see the overall stats. Also gives you some system resources stats where CPU and memory utilization. The more interesting thing is the API services, right? So API services is all API related metrics that it shows you, right? So let's get into directly API service performance. API service performance is this UI where it shows you all the API that we have, and it should have also have my customer services API. See, Temenos customer services. It shows that I have 22% of the complete volume, and it shows my average processing time, right? So it shows that yeah, okay, average is quite high, and the maximum it's like 8193 millisecond. So these are all the testing that we just did right now, right? And what it does is if I can drill down, I can go into this Temenos customer service and show me only this one customer service or this one API and shows me the stats of this. I can change the time frame of this to last 7 days and get a bigger result or whatever, right? And now that I have the, say for example, there are some critical services in your organization and you want to make reports for them for your management or whatever, right? All you need to do is you need to get into the service level and see schedule. If it's say schedule and I go now to my reports page, I would have created a new Temenos customer services report. And if I'm going to open this, it's this report which is created, which I can now edit. I can change things. I can of course choose the output type. I can choose, I can essentially modify this and change the filter. I can like, say for example, now the service name is Temenos, but I can add additional filters like, group method, client name and everything. I can make all these edits and then I can schedule it. I can schedule it for daily, weekly, monthly at a specific time and all of that, right? So it will generate this report at that time. So the idea is that this tool gives you all the consumption, API consumption, and some performance indicators. And all of this can be pulled out very easily into a report and scheduled. So this is what we can do with this tool, right? So there are other things that you can do wherein you go into here and you can create your own custom report as well. So you can add whatever you want and suppose it's zero, right? So you can edit this and basically get everything done. Okay. If you have a specific report that you already have, now you can have like you can also download it with a PDF for that instant. Okay, you can go and also make reports based on like consumers. So say for example, you want to find out this particular consumer for the last month, how many requests did he fire, right? You want to find out that. So this is where you can do it. You can create a report per client. So per client, we have these clients that are using it. And you can then, oh, sorry, this is not the one. Yeah, this is the client. So we can check digital team had these many requests for the last 7 days, right? It's called open weather and it's called these two services. So you can do those sort of filtering and get these stats out. Okay, the idea is that all of this is recorded and all of this can be then accessed by API analytics. So this is where we'll touch upon this. All right, so now the next thing that we're going to look at is some more detailed stuff. Okay, so then the first thing among that would be service orchestration. Okay, service orchestration is what the ask was to show a sequence of calling APIs, one API to another, and for that I already have API created for that. Now we're going to go much faster because we already have you by now I'm assuming you have a comfort with this with what I'm doing, right? So if I look into API Manager, we have the Temenos REST API. So this is the REST API I've created, okay, with this resource path / Temenos. And it essentially, it's just a sample API which is created. So we can create that via Policy Studio, but let's not get into that right now. What I want to do is it has two methods. Okay. First method is check customer and account status. Okay. And the second one is validate customer. So these are going to be used for two different testing cases that I'm going to show you. The first one for check, it's basically saying customer status as the check. It takes the customer ID and an account ID. And then what it does is it hits two separate requests. Okay, they are both REST services. So it hits the Temenos backend with the customer ID, checks if the customer is valid. It hits the Temenos backend. If this is successful, it will hit the Temenos backend with the account ID and check if the account is active. And if both are active, we'll then give the response to us. Okay. So how do we activate this? We go into outbound, advanced. I have created a policy for it. I will show you the policy later. So what I'm going to do is now instead of doing this default policy application, I'm going to show you how to do it per method. So you can also apply policies via at the method level. Okay. So if I say if I select the method here, that is check customer account status, I can now select a policy. So I can do request response and routing here as well, right? So I'll select the routing policy and I'm going to select customer and account live status check external. Okay. It's basically hitting external URL and getting the response. Say apply. And let's quickly test it, right? So if I go in here, I already have a request here. Okay. Which is taking in this customer ID. This is my test data and account ID as the send. Okay, I think, all right, no. This is hitting, while it loads, this is hitting my Axway gateway URL. And internally, it is doing few things. Okay, we'll look into it. So if you see, the response is success true. It says the message customer and account profile is live. Okay, and it returns back this customer ID. So now this, what has happened is internally it has done a couple of things, which we'll now see. And or viewing what has happened inside, like the execution trace, right? I'm going to go into our gateway manager console. Okay. So this is, so until now I was doing everything on API manager, right? But we also have for our gateway or for troubleshooting or looking into details, technical details of the transactions and all of that, logs and all of that, we have the gateway manager as well. Okay. This is more low level. This is not related to API. It's talking about technical transaction at a technical level. It will give you all troubleshooting data. Okay. So when you log in here, it gives you dashboard showing your request and showing your topology and all of this. But the interesting thing that we need to see now is the traffic, because we want to monitor what traffic came in. If I apply, I can see that there is a service here called Temenos customer status. This is the one I hit, right, for checking the customer and account status. If I open up this gives me a complete view of what has happened inside that request. This is one request with this transaction ID. It is a unique ID for that transaction. And if you see, it shows a customer routing path because I selected a policy, right, for it to run. And it is giving me every step of this policy. Now it gives me the status of each step. It gives me the execution time of each step. And of course, the time as well, right? So now if you look over here, right, I have done two service calls. I connected, first I, of course, fetched some attributes. I connected to a customer service. Okay. And if you see, this took like 7510 because it hit the Temenos service. The Temenos service is a little slow. Okay. So it gives me it takes time to respond back. The gateway will respond back faster, but the Temenos service in itself was slow. So then once the customer service was hit and it then compared the record status and says, okay, everything's fine, then it is going and hitting the second service called account service, again, which took some time, right? Because it's a Temenos backend. It's getting the data back. And once it's passed, it's then setting the success messages. If it took a failure, anything failed, it would have shown a failure message here. Okay. Now, this is the execution trait. This is a very, very powerful part. Okay, because just think about it this way, right? You are in production and you have your consumer says, I send you a request and I didn't get a response, or something failed. I don't know what's happening. You tell them, just send me what is the request you send me. They would typically send you something like a transaction ID, or they send you a request object, right? Or the time, one of those indicators. You come to this tool, you locate it either with any of these filters. We have a lot of filters that we can add. You locate it based on time, based on transaction ID, and you get to this level. And now you know everything that had happened in this. You know where it is failed, what how much time it took, maybe it timed out calling some other backend or legacy system. All of that debugging you can do here. What you can also do is you don't have to go anywhere else. You can also get the payloads of the data. Now look at how we do that, right? So if you see, the request was sent by the client, okay, and it hits the gateway first, right? But the gateway internally is now going to call two times. It's going to call Temenos. So first time it calls it with customers for customer data, and then second time it calls the gateway Temenos service for account. So all the three legs, these are three legs now, are recorded. And any of them, if I open, right, I can see what was sent. This was the get request sent, and this was the response that we got, right, which we saw on Postman. But internally, what it sent the backend is also what is recorded. So I can see this is it's trying to validate this customer, and it got the response as this, right? So it says its transaction is live and it got the customer details. So similarly for the account. So this is the level of detail you can get over here. If I go one level, one level low, and I actually I say I want to see all the logs as well, the debug log. I can override this and say debug, okay? And if I go back to my traffic monitor now, and I need to hit a new request, okay, I should be able to see all the logs that this policy went through as well. Give it a couple of seconds. The Temenos backend responds a little slow, but the idea is I want to show you this service because it's very interesting. So say apply again, and I got a new request here. Now you can see, right, there's a lot of logs that get printed out every step of that request. So in fact, getting, I think if there are developers in this call and people who are daily dealing with transactions, you would love this, right? So you would want something like this. You would want to see what headers were there. You don't want anything hidden from you. So you can get this low level debugging capability. And you have to understand one thing, right? It's not pulling out the full log for you. It's pulling out the snippet of the log that's pertaining to this transaction itself. So it's saving a lot of time. You don't have to go to the log file, search for it. You just open this request, you get everything you want here. Get this snippet. You can further on reload with payload data as well. So it will further on add additional payload data related elements as well. So this makes it very powerful for troubleshooting. And typically, this is the most widely used part of the gateway manager when it comes to when you're running APIs with Akshay and all of that.
Okay, so so now the log set is the file, right? Not stored in the database.
No, yes, it's stored in the file. There are multiple logs that options we have as well. So they are stored in files, of course, but post that, like if you want to open it out to, there is an open logging concept as well, where we can do consolidation of this and push it in the DB. But yeah, the ones you see right now is stored in the file. So you can go to the file and get these traces as well.
Okay.
All right.
Yeah, you may continue.
Yes. So that takes care of this orchestration. I also want to show you the policy. Give me a second. Right. So this is how the policy is looking like. This is the API orchestration that we have done. And just to quickly highlight, right, I need to show you what are the different things, elements that are there within this policy, right? So you can see that we have, of course, fetching some attributes, that is customer ID, account ID. And then what we're doing is we're connecting to the customer service. The same thing that you saw externally. This is how we've done it in the policy. We're calling this API Temenos, passing all the data we need. And then based on whether it's success or failure, it's going forward or no, right? So if it's a successful request, it goes into and creates the customer record status. Checks for the record status. If the record status is successful, then it goes forward. If not, then any error case is going through this red arrow, right? But if it's successful, it then goes ahead, creates the request object for the account service. It's basically adding headers and all of that, and then it connects to the account service. Okay, connects to the account service, does the account check, retrieves the account size. Okay, and then it compares and does some comparison and validates if the account is also valid. If the account is valid, it goes finally to this branch and returns a success. So you can now configure this response body if you want. You can do some data mapping and all of that. So this is what it is doing. So this is the entire policy that's getting called. So we generate this policy and then we deploy it, of course, on the gateway, and then we apply it on the API. Okay, so this is, I wanted to show you this whole orchestration of calling two services from one policy. Okay, so you can do it in the backend like this as well.
Okay, what you showed earlier on the API manager is based on this policy, right?
Correct, perfect. That was gateway manager, but yeah, this one, the execution trace that you saw. Each of this step is each of this step in the policy.
Okay, so in the policy itself, so let's say the orchestration itself, for here what you show is just only to query one success, then query another. Let's say the two transaction itself is the financial transaction. Okay, so let's say the first transaction is success, debit the customer account. Second transaction is another financial transaction, but it is failed. We want to do the rollback on the first transaction. So the rollback, we need to configure this policy also.
Yes. So you can, so yes, that's so perfectly. So as you said, right, if the first transaction is success, second transaction failed, right? In this case, I'm just sending a response back because I've made it, a direct response back. That's a failure. But in this return or the failure state, right, you can create. So there is the concept of policy chaining. So you can have a policy shortcut here pointing to a handler policy. So you can have a rollback policy created, which is another policy where you'll do that full rollback action and you'll call that in the failure path. Okay.
So you're saying that one policy can be inherited from another policy also.
Correct. So you create a policy shortcut. So I can call this like rollback or something. Right? I can create a rollback a service or rollback policy. Maybe it's a generic policy or it can be a specific one based on some attributes. You can, it's how you design it. But the idea is you can call any other policy here. By doing this, what will happen is at this step, it will jump to the other policy and do it. So basically, it's like a child policy or it's basically a chain of policies that you can run.
Okay, I understand.
So this is how you can do the error handling. You can do many. You can do it more. There are like, this is what you're talking about is a functional problem, and you're doing a rollback. But if you want a generic error handling, of course, we have error handling filters as well, which are there, generic error and JSON errors and all of that. You can also do a another interesting thing is you can the error handling, whatever policy you spoke about, right? It can be a generic behavior and can be like a, say for example, if I go back to my manager, right? This I think you will be interested in this. If you go into the customer services, if you remember, oh sorry, I used REST API. Too many APIs today. Okay, so you remember I did a policy. I set it according to method, right? So at a method level, so I can either choose do the error handling. Right now, I don't see the fault error. I mean the error handling thing because my setting has changed. If I enable fault handlers, right, what will happen is uh, you'll see that now I get a fault handler policy as well. So I can have a fault handler policy, which I'll do my my edge cases or exception cases. It can be not only at a method level, that can be generic. It can be at a global level within that API. Okay, and your routing can be specific at a method level. So you can, it's very fine grained actually, as well as it can be coarse grained as well. So you can decide how you want to apply the policy. Okay. All right, so this takes care of this orchestration. This was one big example I wanted to run you through. The next is logging and traffic monitoring. I think we saw all of this. I wanted to cover everything together, to save time as well. So we saw how we can look at logs. I just can touch upon one thing quickly. So we saw this whole thing, right, of monitoring, traffic monitoring on payloads and logs and everything. But other than that, since it was brought up, we also have various logs that we maintain. So we have domain audit logs, which are taking care of all domain audit log actions, right? Whatever happens in the system is recorded, right? Then we have transaction level logs, where we put in transaction logs, transaction access, who was accessing it, and trace. Trace is the final dump of all the information. So all of this is stored. This is definitely useful, if especially for auditing purpose and all. So we have different levels of log that are stored. Other than this, okay, if you have an existing system logging monitoring tool like Splunk or something, and you want to use that, like you say, okay, let me have a look at the logs that I have in the gateway. Yes, you can do that. We have a concept of open logging. You enable open logging. What does the backend node managers and the our internal components of the gateway will now in an async way, it will pull out all that data from these files. It will consolidate it in one place, and that place can be then looked upon by the third-party monitoring tool. And you can even get this same data in a report in Splunk. So many of our clients use that. They use ELK, they use a lot of other tools because they already have it, right? And what they do is they just create this link to this log so that they can see the logs over there as well. So yeah, but that being said, we also have many places where you can see it. And you can see it over here at different places. You can even see it in the API manager actually. You can see the logs over here as well. So yeah, the choice is yours. But what I want to highlight is that from a logging and monitoring perspective, we are very flexible and give you so many options. Like we don't want to stop you anywhere. Okay. All right. So this takes care of these two. All right. So the next now is going to be some transformations we're going to talk about. Are we okay to continue? You need a quick break or something? I'm okay to go on. I can talk all day, but I'm just conscious about you guys are listening from a long time.
Okay,
So,
we can continue.
you can continue?
Yeah, we can continue.
Great, sounds good. All right, so the next thing that we do is we are going to see some transformations. So the ask was to show various transformations like REST to, I've written it out here better, REST to SOAP, SOAP to REST, SOAP to SOAP, and REST to REST. Okay, the last one we've pretty much seen this, right? Temenos REST API, which we tested just now, was a REST to REST backend. It is REST API calling a REST backend. Let's look at the first three. Okay, so for the first one that we have, that is the REST SOAP backend. I'm going to use a SOAP service that I already have in place. It's account service. We use SOAP UI for that. All right, so it's an account service which is running on an Azure box. Okay, it's an Azure service that I have, and it basically gets account information via account ID. Okay, so this is the one. So this service internally calls, if you see, it calls Azure websites, and it has this. It's a .NET service which is giving me some data. Okay, it's giving me some data of the customer. This is sometimes slow, but this is all because this service on Azure is not very fast, and it's more because we are in different regions as well. So my server is in Sydney, and this could be hosted somewhere else. So yeah. So now once I'm while this loads, I'm now going to jump into API Manager, and I need. So what I need is I need a REST service to call this SOAP service. Okay. So for that, I need to create a REST service. So for that, I already have a backend REST API created. So I have a REST API spec as my backend. How I created this was I could go into Policy Studio, and in Policy Studio, we have an APIs option. And that's where you can create these kind of APIs. You can create, like, say, customer. I create a customer API. I create methods for it. And then, I can select various parameters, inbound parameters, all of that. So I've pre-created all this so that we can go quick with this, and I've imported it here. So once I come here, what I do is I import it from topology. So if I import from topology, it's going to pull out all the APIs that I generated on the Policy Studio, and it will create this kind of construct for me, which I am here, account info REST API. Okay, it has two methods: check for balance, and yeah, it has a balance check. Okay, so actually, just a second. I think. All right. So now what I'm going to do is I'm going to just create a front end layer to this account service. And inbound security upon now for testing, I'm just going to keep it passed through because we have already checked the authentication part. All right. So the backend, right? It is what it is doing is this account service is calling a policy, and this policy is balance check. Okay. Yeah. So this is what it's doing. It's calling a balance check, and it's basically doing something. Let's see that later. First. All right, so this is how originally the service gives us. Okay, originally, if you see this service, unfortunately, some of the fields I cannot make enlarge it. But yeah, I'm giving the account ID here, and it gives me the service in this fashion. You can see how it's I don't know what way to say it. It's pretty ugly, right? So it has like a very high level or low, sorry, rather low level technical keys, partition key, row key, e tag, and way of giving me the account details, right? And give me the balance information, account balance. So I want to use this service. Say this is your backend legacy system giving you this service. They say, I don't want to make any changes. You build your service, do whatever you want, right? This is the data I'm giving you. Now we build this REST API, which is on top of this, which is calling this service. And within the policy, let's see what we can do, right? So before we see the policy, let's run this service directly first and see our output, okay? So account info REST API, I already have this here with the same account number. And I'm just going to hit send. Okay. So if you see my response for the API we have exposed is much cleaner. It has an account construct having account customer, just 4 details, because this was what was essential for the service, right? It's giving me the balance information. Okay. So it's much cleaner than what the backend gave me, right? So how did we achieve this? Let's go into the policy now. So what the policy does is it extracts REST attributes in the first, okay? That is, the headers and all of that. It validates this account number. So the account number that I passed, it'll check if it's alphanumeric or no. We have other validations that you can do as well, but you can pretty much do a lot of other checks as well, or you can add. You can check for threatening content. You can do all of this validation under this block. Okay. Once we do this and it's successful, now it has to create a SOAP request and call the SOAP service. So it creates that SOAP request with the runtime query string, okay? And then it basically calls this account service. So we're calling this account service, passing all the details. And finally, once the response comes in, we have a filter called conversion filter. This is one of the many filters we have. Okay, so the response from SOAP comes into XML, right? So it takes this XML, converts it into JSON, and it automatically converts. And you can choose any XPath to convert. You want to change anything specifically, you can do that. All of that. It does this conversion. So the first level conversion is take the XML that you have, just blindly use that XML, create a JSON format. Okay, it does that. It converts this, and this is just setting the context type. That is like text application JSON, which it has to do additionally. And then we check from that converted JSON, right? We check for the account ID. Okay, we get this account ID, but this JSON is in a very, again, it's a JSON format, but it's using the same construct of SOAP. If you see envelope, and if you're familiar with SOAP, you'll know, right? So it uses that, extracts the account ID, and then we just check for the account ID if it's not null, and then we are in the success part. Now, before sending this response, we do something like this. This is very, very interesting and very important to see. So this is something you've not seen till now. We are doing something like execute data map, right? Because we just don't want to convert into JSON and just send it, but we want to beautify the response. We want to make some transformation. We want to build a response in such a way that our consumers don't have like, an hassle to understand it, right? So for that, we have something called as data map, which uses a visual data mapper feature in our policy studio. So let's look at what it is, right? So what we do first is we build schemas of this JSON, like the input, the account data JSON. So we build schemas of that, and we import the schemas under JSON schemas. Okay, very easy to do this. If you just pick up any JSON object and you can either use a tool or you can backend tool, or you can even go online and build this in one click. You can build this JSON schema. So this is sort of the schema that you can build based on the output you have. Okay. Once you do this, most of the job is done. All you need to do is build a data map. And this is an account info data map that we have. What this does is, I'll just open up everything. So what this does is, this is my source JSON. This is what, after converting, right, I used XML to JSON. This is what it converted it, and this is the construct. It has envelope, body, exactly soap style, but it is a JSON format. Okay, and it has all these ugly fields, right? Partition key and e tag and all of that. And then on the other side, as a target, I can choose the format I want. I wanted account, just 4 fields for me. Okay. Now we can do we can drag and drop, and you can basically just map the fields. Okay. You can do that. One thing is that. The other thing is you can merge the fields. If you see, my account field, right, is merged by 2 things, partition key and account type, because I don't want to show 2 fields. I'll just show an account type dash hyphen account number. So if you see this thing, if I open this up, it tells me what arguments I have. So the first thing is the account type. Second, I'm adding an additional text. You can add a text as well, and then I'm giving the account number, right? So you can do any sort of transformation. You can make it like a cap. You can change the font. You can change the date formats. All of this. You can do all of this creative things here, and that will then get mapped to the destination format. So this is the drag and drop way of mapping. This is a very handy tool, and a lot of people use it because it just makes your life simple. And you can have these standard, right? So say, for example, these account, customer, transaction, these are model objects, we call them in APIs, right? Or resources. This doesn't change. Your APIs around it will change. That I can agree. But this is a one-time creation of a data model. You'll create that in your project first, right? So you have, okay, this is the set of data I have. This is what I have. So you create this together. Finally, your data maps can be specific to your API. You can create a separate data map for a different API showing only these fields. Right? So this is where it becomes very handy. Once you create this map, all you need to do is invoke this map under this filter, data map filter, where we show what JSON we have and what is the map. So this is the map I selected, that is account data, account info map. Okay, so this is how I essentially what I've done is I've called a SOAP request, got a SOAP response, converted that XML to JSON, and then transformed that JSON in my data map to to a more readable and beautified that response. Okay, and that's how I get this, right? I get this account where you see this is the concatenation. These are 2 separate responses actually. Even this, the card type as well as the card number, right? So all of this has been transformed and mapped with this tool. So I showed you transformation here. I showed you data mapping. Showed you a couple of things. There are a lot of things you can do. You can do another innovative thing. After the end of this, maybe some legacy system in your organization just needs a file. It says, hey, I just accept files. Don't talk about APIs. So what do? You can then file upload to FTP server. You can use this, dump this account JSON into a file. I've not activated it, but yeah, you can dump it into a file. So not only file, you can dump it into a JMS. If you have some messaging backend, you can use our JMS filters and dump it into a JMS queue or topic. You can do that. Okay, so you can do a lot of things in this policy. So it's very powerful if you use it efficiently, right? So the idea is the capabilities are high. Just by creating one policy or a set of policies, you can now use that in a reusable way across all your APIs. Okay, so with this, we have seen like this transformation. This was the biggest transformation that we need to see something new, right? REST to SOAP. So this takes care of the first one. Second one is SOAP to SOAP. So, sorry, right. Oh, sorry, SOAP to REST. Okay, so SOAP to REST. For that, we are going to see another service. It's the same backend actually. That is Azure Services backend, but it's a customer service backend. So it's basically taking customer ID, getting customer information. And for that, I created this. Let's go to API Manager. Created this customer info REST API. No, sorry. I have a customer service, a WSDL file. Okay, so this is the WSDL for that customer service which I'm going to use, and we are going to now what we are going to do as per the test cases, we are going to use this service and internally called a REST backend. Okay, so what we'll do is we'll import this WSDL quickly. Just copy this. Oh, sorry. So I'm going to select the WSDL option here. I'll give this URL. Same organization, the same port. Okay, and now it has imported this as two services, you can see. I'm going to just quickly virtualize this service. I'm going to select v1.1. Okay, and now I'm just going to make this pass through for now. All right, so I have a API now created. I have some methods. I have this URL as well, which I internally can work with, right? Now, for testing this service, what I need to do is I need call a SOAP request, and then internally it will call a backend, right? So before I do that, okay, so now I need to route it to a policy where I'll do this transformation. Okay, this is a SOAP request that SOAP API that I've created here or registered here. And in the default method, right, I'm going to select this SOAP to REST option. Okay, this is internally calling a policy. We'll just say apply. And if I go into my SOAP UI now, because it's a SOAP request, right, I'm going to fire this instead of calling this particular website directly. I'm going to call, one second. I'm going to call my APAC demo environment, okay, with the same ID, okay. So what this is doing now is it's calling this SOAP service that I've exposed. It's going back, hitting a REST service, getting the data, converting it back to SOAP. So I've got this response back. This is the customer details for this ID, which is bend over. And okay. And what has happened at the back end is it has called the SOAP here. So it's easier to look at it from the gateway manager, right? So if you just say apply here, you'll see that my request, okay, it's called this policy called SOAP to REST, and it has converted XML to JSON, done all this, called the customer REST service, and then again extracted the response attributes and set the response message back as SOAP. Okay, so this is how it has done it. So you'll see both the requests here. You'll see the request going to the service, and you'll also see you'll see the SOAP and the REST. So it's actually very useful to see this. This is the SOAP request and the final response, and then the internal REST call that it made. If I look at that, this is the response that came in the REST format. It converted it back into SOAP. Okay, so this is the first test. As a policy, I built it here again. You would see the policy here. It's similar now, so I'm not going to run through this. It's just calling a customer REST service internally and doing this transformation before and after. Okay. I The final case in this block is soap to soap. Okay, so this I can use the same service right now. All I need to do is I need to change the outbound policy to soap to soap. Okay, and say apply. Okay, and if I hit this service again, it's again going to give me the response in XML. Okay, and now if you see the gateway manager, what executed, right? Now you'll see a different one. So basically, it's calling a SOAP service. So internally, it's not calling any REST service. It's calling the connect customer web service to the SOAP service itself. Okay. So both the requests and responses are SOAP. So if I see the response here, the response from the internal service is also XML. Everything is SOAP. Okay. Ideally, you don't need to do it. It's just a SOAP service. But this was the ask, so I just I just want to touch all the points. So the last one is rest to rest, which we already seen in the orchestration example, right? So I will consider all these cases are tested and a market as green. Okay. So these are various conversions you can do and transformations and all that within that. There's one more which was additionally mentioned, and that was calling one soap and one rest. Okay. So for this, I have simulated this with the example I showed you before for Temenos, right? Where we did the orchestration. So under that, right, I have another policy. First one we saw was checking the customer and account status. Both were REST, right? I have another one called validate customer. Okay, and validate customer, I have prepared a policy for calling a SOAP and a REST in one policy. Okay, so this is the validate customer that I'll set. I'll apply. And I just need to call this service with this method, right? So because this is a REST service, I'm going to go back to Postman and click on validate customer, soap to REST, soap and REST, and I'll say send. Okay, so this is going to go back to Temenos and the Azure sites, both the websites actually. So first check the customer details in Temenos, then get the response. If it's successful, go to create a SOAP and request and create a call the request in Azure. And it has hit both the websites and checked and seen that the customer profile is active. Okay, so now if I go here, this is the also a very interesting example because you can see both the request in one. So if I select this and say this one, right, I select on this part. Here you can see the traces. First calling a REST SVC, okay, and then it is calling a SOAP service. Hence, we'll see this first request that goes in from till the gateway, and then the gateway making the first call, which is REST service, okay, having the REST response. Gateway making the second call, which is the SOAP service, which is XML response. And having the capability to read both of them, we can merge all of this in one policy and then just give the final response to the consumer saying, hey, this is what it is. I just gave a very simple and easy response. He's active. This is the customer ID. So this is how you can do all sort of orchestration, transformation, logic, everything within policy. And make things very simple. You make a lot of reusable stuff with this actually. So I'm going to mark this as green. All right. So this takes care of all the transformation bit. The next two that we're seeing is database. Okay. Now this is only database connectors. Okay. So this one we can do quickly. One that is there is to read through database views and procedures. Okay, one second. I need to give me a second. So I created a backend database and I created this as well, view and a procedure as well. So just let me open that. So we'll use that to simulate this test case. Okay. All right. So if you see, I have a customer table which has these values, like they have two entries here, and a customer view which picks up this, but only picks up a few values from this view. That was what was asked. It picks up like only an ID, name, and status, and then gives this response. Okay. Um, so before the view, there's also stored procedure. The stored procedure says that you need to show some sort of invocation to stored procedure. So the stored procedure that I have prepared is more about inserting a data inside this customer table, and the view is to view the data, okay, in this format. So first, let's go to API manager, and I've created some DB API. You see customer DB API. This is just for, I've given these names which are very technical. You don't need to do it in real time. This is just so that, our POC, we can relate to it in an easier way. But yeah, these names are not like, we can give them more functional names, but this is just for the POC, okay? So given this customer DB API here, and under this, it basically is calling, like what I'm calling this is like the backend is a CRM DB. It's calling this, and what it is doing is it's essentially going in there and running a policy which basically can do things. Okay, so I am going to go to my Postman. The first thing is I will try to post a request. Okay, I'll add a customer in the DB. Okay, I'll send a few details of that customer. I'm sending this customer is Michael Brown. His status is live and all of that. Okay. If you see in my DB, I do not have this customer. So if I run this again, I do not have Michael Brown. I just have John and Jane. Okay. So go back here and hit this request and say stored procedure executed successfully. And now if I run the same query, right, I get Michael as well added. All right. Now now I'm going to check for the view. If I hit the view, like that, the other request. Yeah. So this is just going to this is essentially just calling doing a get request and calling for the customer, latest customer. That's what how I set the view conditions. If I say send, right, it's going to return back the latest customer, which was Michael Brown, and the live customer. Okay. So what happened in the backend was this API that we invoked, right? It called two policies. There are two methods, right? Each of this is calling a policy. Okay. One is adding a customer, calling a stored procedure, and one is calling a view. Okay. Having a quick look at the policy because we've not seen database connectors. Adding a customer is basically, yeah. So what I'm doing here is this is the policy which is calling the stored procedure. So I'm going to just retrieve some data, and the interesting thing is to call a filter which is going to read or write from database, right? Under this, I can create a statement, and this statement can be a stored procedure call, a function call, any insert, update, query, whatever. So I'm calling this, I'm writing my stored procedure input here, text variables and everything. This is a default database connection, and I say finish, right? Once I get this, I can set the response across that. So basically, I just had a table here, and I created a full API, okay, which is calling this, right? This table. I didn't have to have a backend also. So this is how, if you have some tables and you just want to export the API, you can do this like that. Okay. You see this API here, the customer DB API. So calling the stored procedure, this is the method, right, which we called from Postman, and it is routing to this policy. So you can have a backend routing policy like that also, and then deploy this on the gateway and then test it. Okay. So this is doing stored procedure call. The next one we tried was we viewed it, right? So for viewing it, I fetched the customer from the CRM. So for that, again, I retrieve from database view. Same thing, call the same connector, create a statement, but in this case, it's a query and I'm querying from a view. Okay. And then accordingly, I then set the response and everything. This takes care of the first part of doing things, right? The database view, procedure, and all of that. The next one is doing the same thing, like similar thing, but with transactions. So the use case was to basically create an so we have basically a core banking system, CBS. It has 10 fields. That is a big table. Okay. And we have a transaction table. Okay. The idea is that we need to create an action to connect to this backend. So basically, it's like that CBS table gets some data to process. Okay. With the it has all the 10 fields. Now our API has to take care of pulling data from that table and then dumping specific like ID, amount, status, and all of that into our transaction table. Right? So we have to do that. So for that, I written a policy again to do that. But let's see it from the execution standpoint first. So this is my CBS table, okay, which is my core banking system table, which has 10 fields, okay. And if you see the state post processing, I've made this field so that we can track this. So post processing is still pending, right? So it's waiting for some process to run and do this. And this is my transactions table. If I run this, okay, it has up to 1005. It doesn't have, it just has the last entry is 005. Okay. So what I'm going to do is I'm going to run this API. I think I already have it configured here, which is my uh, transactions DB API. So this is the other DB API that I have. And this is internally calling those policies. So what it has is it has various methods like add transaction, fetch transaction, process transaction. So I'm going to call this process transaction from TBS, from CBS. So it's going to go into CBS, see if there is any pending record, pick it up, process it, and insert it into transaction table. Okay. So I'll just run this now. So I have a test case here to process transactions from CBS. Okay. I'm just going to run this. And it says transaction 1006 process successful. Okay. So if I go back here into my DB now, and if I run the CVS record first, okay, it says that the post processing is now complete. Okay. And my transaction table where it inserted the data, if I run that, it's going to show me another new entry called 1. Right. So I entered this and it is picked up specific fields of that request and entered it. Okay. So that was one ask. And the other ask in this was to also now have a way to use this transaction ID and then search for that data. So let's fetch for that same data, right? So you have transaction 1006. We are going to use this transaction ID to fetch. This is a fetch transactions as well, which takes transaction ID as parameter, same parameter, we send. And yes, we can get the ID and details, right? There are the details in the transaction. So this takes care of all transaction related, or rather like regular querying and insertions and all of that, right, into tables. So how we did it is the same thing. I'm not going to run you through it because it's the same way how we did it for the views. Just to understand quickly, this is the processing part, like picking up from the retrieving data from CBS and accordingly processing it, connecting to, I'm basically creating a transaction record and validating the response. And finally, if the response is it's already created, I'm updating the status in the core banking system to complete it. So this is how the policy looks. Okay, this is the flow chart. So this takes care of this transaction related stuff. Okay, of creating and processing data and querying it. Okay, not risky. All right. So we pretty much completed now all the old cases. Now we have a few new cases that were asked. This should be relatively quicker. So one of the new cases that was asked was to show best practices for access identity. Like, say, for example, you have some APIs which you want public access and some for internal access, right? For internal APIs. How do we maintain that? So if you remember, some time back, I spoke about organization, and that's what we're going to use here. So you go to API Manager, right? I have API here called FinHub API. If you see my API list, right, I have FinHub API, which is unpublished. Okay. Now, how do we maintain public and private APIs, right? So I would not say private, I'll say non-public. Okay, it's public and non-public APIs. So we have organizations. So we create organizations, and if you want anything to be public, so when you say public APIs, I should be able to log in into the portal and be able to access it. You remember I showed you a Commerce Bank, right? They allowed me to see the APIs. They had public APIs. Okay, anybody like me, I without logging in could go and without signing in could see their APIs. Whereas UOB doesn't have any public APIs. So similarly, we are going to create that structure here. So if we have public, we can create a new org called public API org, under which we have only APIs under this, right, will have public access. And if you see, this FinHub API is a part of this org. Okay. Now, other organizations like Digital Team, which we were using, they are all our non-public APIs. Okay. So now if I go back to the API view, right, if you see over here as well, I can see the FinHub API, which is a public API, right? And I can see other Digital Team APIs as well. So let's do one thing. Let's go and see how it is appearing in Portal. Okay. First of all, if I go into Portal, I have already signed in. Oh no, I haven't signed in. Okay. Let me sign in as okay. So if I see here in my API view, right, without signing in, I'm not signed in. I do not see the FinHub API, right? And even if I sign in, right, as a developer, okay, I'm unable to see the API. Okay, so let me now sign out. And I'll do one thing. I'll publish this API from API Manager. So once it's published, right, and if I go back to my home and I click an API, right, I'm going to see FinHub API. Now, this does not require me to sign in. I can go in here and I can test this API, right? Pretty much do everything. I can test it. It doesn't ask me for authorization if you see. Okay, I can go in here and test this API. All right. Whereas, so this is how I'll have local or rather public APIs, right, to be seen. But if I sign in, right, sign in and log in as a developer or a user, you can maintain all these APIs in a separate organization, and those APIs will be all my local APIs and will not have all the public access. So essentially, you can divide your APIs by building two organizations. Okay, two organizations, one as the public org and one as the local team org. And then those organizations, this can be one or many orgs, public org like this. But essentially, all these APIs will then appear on the portal. And of course, on the portal, you need to do one setting to enable public APIs. But once you enable it, the users can just click on the portal without signing in, can basically, um, you know, view the APIs and test it and all of that. So they don't need to register. You can choose what APIs you want. So say, for example, you want some APIs just to have a view on things. So earlier DBS Bank had a lot of APIs exposed in the public portal, but then they realized that, hey, a lot of people are using their structures, right? They're basically mimicking their style. So they moved all of them to internal portal. So you need to be a consumer, because when you have non-public API, you can control it, right? Because you know who is accessing those. You know all the users who are there on the system. Logging in as an admin, I can go into my internal org and see the users, right? I can click on the users here and I can see these are my 3 users. I can actually track and I can even revoke their access, right? I can remove these users as well. I can disable them, I can deactivate them. I can do all of this if you have making them sign in. But if you're keeping it as public, you basically cannot. You will see the API and everything, but you basically The consumers don't need to get any of your approval to do the testing and everything. Takes care of the first bit. The next thing is CI/CD, right? So whatever we saw right now, we did. So this is like more like what we did was from the UI, we onboarded APIs, we did the full life cycle management, we added applications, a lot of steps we did. All these steps are possible to do in a headless fashion in the backend via a automation script. Okay, so you do not need to really sit and do manually all of these things. Okay, so any kind of updates you want, you can completely chain this process in a backend automation. So how do we do this, right? So first of all, let me introduce you to Axway CLI, right? So we have something called as we have a APIM CLI, okay, APIM CLI, which basically can get into which you can configure, and it is a CLI way of seeing everything. Okay, so if I just click on this command and say it's basically going to check all the APIs, so you can see it is giving me a list of all the APIs that are there on my API manager, right? Each of them is having a unique API ID. Each of these IDs is the unique identifier for the API actually. Okay, so you can do a lot of things, like you can do everything here. Like if I just go in here and just say APIM help, right? So you'll see what all it can do. It can import, delete, publish. It can, get the request, upgrade. It can approve. It can do all the things that I was doing from the um, um, UI, from the UI, from the API manager, right? So this is just API help. But if I just go to APIM help, then it should have other things, like it can make changes on the settings, it can make changes on the application level, organization level, user level, everything. So it's a very expensive CLI tool. This is the tool you'll use to plug into your automation so that you can do all of this, whatever I was doing on the UI, in a headless fashion. Okay. Now for testing this whole thing and showing you and demonstrating, right, I'm going to now import and add a new API. Okay. Until now, we have been doing it with this UI, right? We went here, we registered the backend and all of that. I'm not going to do this. What I'm going to do is I have created um, a source code repo. I have a GitHub repo here, which is called actually API. This is basically having some construct. Okay, don't worry about it. It's just some standard construct that needs to be there. It'll have some environmental configuration for my for my current environment, right? Some property files and all of that. It has shown basically just a one-time configuration, and then uh, it has some specification and a config file for my API. So one is a spec, which is basically the an API spec which it is taking. Okay, it's taking this, you can download from anywhere, right? How we downloaded it for Temenos. This is for Open Weather. Open Weather is an open service which basically gives you weather information. Okay, so I'm going to use this. And then at the config JSON is more like a construct for us internally. So it's telling what is the name of that API, what is the backend base path, what few things that we need to set. Okay, what is the authentication? Is it linked to any applications and all of that? Okay, so now these are the bare minimum two things you need to now build automation around it. Okay, so I'm going to import this Open Weather API into the API manager, and I'm going to do it in the same organization, like the digital team, link it to an application and everything. Okay, so for that, how will I do it? I need a tool to now read into this GitHub repo, pick up this data, take the CLI and run and create these records, right? So that tool, I'm using Jenkins. Okay, I think Jenkins was mentioned in the example also. This can be any CI/CD tool that you need. Okay, and I created a pipeline called Axo API and CI/CD, which will basically pick up the entries from okay, pick up the entries from my GitHub repo, and then it's going to run it. So let's just run it, right? Without doing anything else. Let's just run it. So I just say build now. Right now it's manual. Okay, just hold on. I will automate it very soon. So if you see now, it is now going to check out from the SCM. It's going to load the containers, done everything. If I uh, quickly see the logs and I go into the console output of this, you can see that it has now imported, it used the CLI, of course, what I showed you from externally, and it has read this definition file called JSON. Okay. And then it realized there is no API created. And then it created an unpublished API. It created an API. Okay. It created an API access also for it that linked to that internal app. You remember the same thing that you used to do from the UI, right? And finally, it has, it has completed the access and then it has just created a successful message. Okay, so it's done everything. So if I go now to my API manager and I refresh, so it would have created open weather here at the backend. Okay, as well as it has created a virtualized layer for it as open weather on the front end. So if I open this, it's created everything for me. It has created the change the thing. It has even linked an API key to it and all of that, right? It has done even the authentication profile it has set. Okay, so it has even linked to me. This one step has linked me even to this application. So if you go to application internal app, right? You can see it has already linked it to the application as well. I didn't have to touch the UI. Now, without doing anything after running that job, I just go here and suppose I test it, right? I'm going to test it. So ideally, it is now working and it's giving me the weather information, right? So it gives me all the weather data. Now, say for example, this automation is good. I mean, it's doing everything. I would say this is more than automation. This is a headless way of doing it. It's a back-end way, no non-UI way of running this thing, right? Now, what if I want to automate it further? I want to build the pipelines as such that, I just need to make any change that I make, right, will automatically trigger this pipeline. Okay. So for that, what I'll do is, let's take this use case, right? We have open weather map created here, right? Sorry. We have this API created here. And I want to change maybe this name just for showing some change element. It can be anything, right? But I want to change this name to Open Weather Map API. Okay. But I don't want to do it by the UI. And I want to automate it. So the thing I want to achieve here is if I go into GitHub, right? If I go into GitHub, any change that I make into GitHub and commit, okay, it should automatically now generate a pipeline and create everything. So what I've done is I've used the concept of webhooks. Okay, so I created a webhook on my GitHub repo. Okay, and in my Jenkins pipeline, I go back to the project. I just need to enable it. I need to go to configure. And if you see, right now it doesn't have any build triggers. I'm selecting a build trigger as GitHub hook trigger, okay, so that it is going to now listen to any of the events that get fired from GitHub, okay, and as I say. So now if you see the last build that happened was 44, right? And the name of this API was Open Weather. So what we'll do now is we'll go into GitHub and change the name of this API. Okay, but instead of doing it from here, right, I already have pulled out this repo code in my local system. It's just easier to do it here. It's the same GitHub repo, and I'm going to go into config, open it, and change this name. Okay, this is just going to simulate some name. I'm going to make it map API, right? And say save. And now I have going to git commit it. Okay, I'm going to commit this and say updated name. Okay, this is the file I'm committing as a commit and push. So once I do this and I go back to my Jenkins page, right, you'll see very soon because of this change, it has now automatically triggered some change action that GitHub has notified. It created a queue. It's running a pipeline, and now it's making that change. I didn't have to touch anything. All I did is I changed the code. I mean, code as in I changed the configuration of my API. Right? Just ran it successfully, And now if I go back to manager and I refresh, the name has changed now to Open Weather Map API. All right. So I'll need to just let me refresh this as well. Yeah. So if I go in here and I see my API, yes, I've changed it. So this is just to simulate how the change management can work, right? I didn't have to touch my UI. So you can build a complete automation pipeline like this and have all your code and configuration into your source code repo. This can be any source code repo. And any event that happens, you can use the pipelining like this to get triggered and then use internally the Axis CLI to do all the deployment onto your gateway. All right. I hope I was able to demonstrate this, as per what you wanted to see. So this is this piece where I wanted to show you the complete real deployment. And this can be done to deploy into different environments also, right? Because as I said, right, we have different environments here. If I go in here and I showed you in the initial config, I showed you that there was the environment config. So you can choose which config you're loading. So at the start of the pipeline, it loads the config. It loads the config, and then as a first step, it loads the config. Okay, it loads the dev configuration in this case, and then it replaces all the variables that are there in that config with the dev configuration. So here, the dev properties are different in production. So this same pipeline can be used. You can have different pipelines to run your code into dev, to run your code into production, and all of that, right? So you can build a whole CI/CD and DevOps automation around APIs using this. Mark this is green. So we are left with this 11 minutes. There are very few things left now. Okay, I'll just quickly close this. The next item is policy. Okay, so they said that if you want to customize Policy Studio logic, how will we do that if you have some code or you have something that you want to do? We're going to use the same API Open Weather, which we already have imported. And what we can do is we can actually say, for example, at this point, if you see the response, right, it's giving you the response in temperature. It's in Kelvin, but there is no degree Celsius. Okay. Say I want to convert this. I don't want to do this conversion, but this conversion, I don't have a ready filter for conversion of temperature, right? I don't have that in my policy to do. How do I do it? So first, let's apply the change, right? What I can do is I can go into outbound for my open weather map. And under advanced, I can select a different response policy called add temperature in Celsius. Okay, I already have pre-configured this policy, apply. And now that I run this again, right, what I'll get is I'll get the temperature. You see, this field wasn't there before. So it's the temperature in Celsius, which is a different temperature, right? This is added to this list. How did this happen, right? If I go back to the policy now, and sorry. Right. So if I go in here and I check for the open weather transformation policy, a very small policy, but the idea is that it is using, so I get the JSON, of course, I get the JSON temperature, I get the temperature in Kelvin, I get that data from the request. But how will I convert it? I don't have any filter, right? So we have something called as scripting language filter. Scripting language filter is a way to add any sort of code in JavaScript or Groovy or Jython or whatever, right? And what you can do is you can basically, here is where I have written an invoke message and I've taken this, everything, all the data that we store, right, as input and output to this filter. The data will be in attributes and they're stored in a form of a map. And what you need to do is you just need to get that attribute and then do whatever calculation you want to do. So I have done, any logic actually. In this case, I've just done the logic is to convert it into Celsius. And then I'm responding back in the same map, but with a new element field, right? So this is an attribute. And then once I do this, I can then just do my regular things. I can get that field and then say add these modifying and playing around with the API related objects is already there. We already have this function like to add a node to the JSON and set a message and all of that and be reflected back. But the idea is that this scripting language is a point or an invocation point where you can now add some custom code to basically do some logic, or you can use this to call a Java function or a utility as well, which you already have. And if you feel that I need help to build this function, open the script library. This again gives you some sample codes, right? So say, for example, I want to, I want to test and I want to remove a user attribute. I click on this, it will give me some sample code, right? You can also create more in this library. Like if you're using some common codes, you can add this. If you want to base decode or encode this, you can get some sample codes, right? So this is just to assist you even more. Okay. And this with this pointer, right, you can actually extend this and call any backend code, and you can do sort of configuration and changes from a code aspect, right? So this is what I want to demonstrate for this, that we can do in Policy Studio for any complex logic. You can implement it with coding, right? Okay, so this particular piece I'm going to park. This is like, I mean, I don't know how this is planned to do. Maybe this can be done offline, but this is for service performance, which this is about like, testing an API from gateway as well as from your internal. This. We can use the Open Weather Map API, which is an external API, which we can test. Okay, I have it already on the gateway, but I can pass you the specification if you want to test it without Axway, and then if you want to have a look at the difference. Okay, so we'll park this for now. The final bit is just talking points, which are few slides. So demo best practices for environment setup. So I'm going to now, I mean, the demo part is done. I'm going to jump into the slides and talk about architecture and deployment. Okay, so when it comes to architecture and deployment, let me enlarge this for you. Okay, so primarily we can have different setups. One setup is one tier setup. So this is a typical one tier production setup where you have a trusted zone and a DMZ. Okay, where you have you see two nodes, but this is one cluster. So this is supposed to be one gateway instance, one gateway setup having two nodes because it's set up in a highly available way. You have your portal and your gateway sitting as an edge gateway here onto your DMZ or your external zone. Okay. Internal zone, you have your backend services, which are there, legacy services, and all your data. So usually data is always a concern. You want to bring it out. So you have all this is not customer data, right? Because API is a stateless a machine, right? It just stores configuration and certificates and any sort of key value pairs, right? So those are the things which any operational data we store in Cassandra, which you can keep in your trusted zone. Okay. So the communication happens via a firewall and all of that. Even an analytics piece and your backend RDBMS and everything can sit in your trusted zone. All you can do is you can create an external gateway, which looks like an edge gateway, and the portal, which is of course for the developers. The other way to set it up is a two-tier setup where you can have a separate gateway for internal and external. So the same thing over here. The only difference is there's an additional block here which comes in the trusted zone, and then the request can get diverted into the trusted zone. Okay, everything else is the same. A little difference in this is that you can also this can be now in a hybrid way as well. This trusted zone can be your on-premise to, have close latency to your local internal systems, and your external DMZ setup, right, can be on a cloud. So you can have a cloud and an on-prem, and this can be a hybrid setup of the gateway. Okay, so this is a multi-level setup of the gateway. This is also one setup. Similar to this, you already have high level availability in the cluster, right? But you can also have a DR environment. I've not shown that here, but it will be a copy of this, and that will be in a complete different data center totally, or a different cloud region as well. So you can have another one which will be having a global load balancer in case of any disaster. You can set it up that. From a database point of view, we support clustering. So also Cassandra has, you can with a minimum 3 node, you can have quorum consistency so that you ensure that more than one redundant copy of the operational data is stored. So if you lose anything, you still have all your APIs, policies, configuration, which is stored here. You'll have all of that to reboot and get it on the server back. Okay. So this is the 1 on 2 tier setup. This is what decision you'll make. There's also multi-DC setup which you can have. So say, for example, you have two DCs, one DC1 and DC2. We have a concept of gateway group. So gateway group is a logical group. Okay, so logical group of all your gateways. Don't look at the internal components; it might get confusing. Just look at the API gateway part. Okay, so these are each single nodes of the gateway. Two of them running in one DC, two of them running in another DC, but all four I can put into one group. So basically, you are putting, you're having an HA across DC. So now this is one level higher. Here, this HA is within the DC. In this, your HA is going across DC. I'm sorry. And you can do it at all levels. Even your Cassandra, right, can be an HA across DC. So there'll be a replication across all nodes. So this is an extremely highly available environment, okay, which you want to maintain. And this is also one fashion you can have your setup done. Lastly, if you think of containers or deployability, you can also run API gateway onto containers. Uh, don't look at other things. Other things are standard container. This is the reference architecture for our AWS setup. But we can have like a Kubernetes cluster, and your API gateway will run in an EMT mode or rather container mode onto your Kubernetes cluster. So your gateway and manager will be like pods, which will be running, and that can be run on any Kubernetes cluster, and then you basically create all the automation around it and everything. With Cassandra DB, of course, we do not run on the as a container way. We run Cassandra DB still on a VM, and that's for now. That's how we need to set up in a container architecture. Okay. All right. So I think deployment and there were some questions on deployment. So how you move from one domain to another domain. I just want to touch upon this slide. All the configurations you saw on Policy Studio, we can download it as a config. You can export that as a policy package, which will take care of all policies, listeners. It will be a .pol file. Okay. So you can basically go into this and say export, and then you can download it into one of these files. Okay. So we have a policy package which will take care of all policies and listeners and everything. And we have an environment file which takes care of environment specific things like all your IPs and all that, certificates and all that. But if you want to pull out everything in one go, you have a combination file called a thread file. So this will take care of everything, the whole deployment package. Okay, so this can be one package for each environment, and then maybe if you want to deploy it in another environment, you can do it via that as well. This same file you can store in your GitHub repo, and your automation can then use this to deploy as well, manual or whatever works, right? The idea is that this is the constructs how internally it's stored. This one I went through it again. I went through the whole automation for you. The first time I had not gone through it. I just kept these slides. All right, but I showed you the automation, right? So yeah, so this one was all deployment process and automation. Then we spoke about auto scaling. Auto scaling depends, basically because we are having multi-node architecture, we can scale. If you're running it as a container, you can auto scale it as well. And then you can have like streaming integrator. You have async capabilities. I spoke to you about that, right? You can have basically have um, connection to backend queues and backend topics. Okay, you can build that event-driven way of managing your APIs as well. Okay, so we have a sync way of communication, rate limit, and all of that. For monetization, you can also use all the API consumption data, connect to any of your backend tools. Like we also have integration with the Curly and all of that to basically monetize all these APIs that you have on your portal. Okay. So Lastly, I think these are just questions for migration. I don't think so. This was answered last time, wherein for migration to existing services, you need a common construct, as I told you. For migrating any data from your old to new system, if it's policies, it's going to be the all .fed files. But if it's from your old system, you can download it via JSON or Open API specs or WSDLs, and then you can import it within your new system. Okay, so that's how you will have to do the migration. Um, Uh, this last point is about whether it is the same package or no. Okay, so this is all same package. So the subscription cost that Chris will give you or would have given you would be both of them are combined. So we don't have anything called as EI, but it's Policy Studio. What you're talking about, EI. So API Manager, Policy Studio, whatever I showed you, all of this comes together. Analytics and I think not analytics. API Portal might be had different. They have different components, but I think that you can take during your commercial discussion. Okay, so there's nothing to show in a POC.